Hi guys, Dr. Kruse, elementary statistics, and this is just a quick explanation of experiments, observational studies, simulations, and census. Okay, I'm going to start down here, kind of out of order. Observational study versus an experiment. Now, I kind of explain the difference between these two as a deer hunter in a deer stand. Some of you guys hunt deer, some of you don't, but you know people who do. And they basically set a chair up in a tree and they sit there really quietly and they wait for a deer to go by. All right. Now what happens then determines whether it's a observational study or an experiment. If the hunter, the guy in the tree stand, just sits and watches, just observes, doesn't make a sound, and the deer walks by and it grazes and it browses and it just does all the things that deer do, and maybe it just kind of wanders over, to this pasture a quarter mile away or whatever, like it was going to do. That's an observational study. All right. The guy in the tree stand is observing. He could be taking notes, he could be just watching and stuff like that. But as long as he doesn't interrupt what the deer was going to do, that's an observation. That's an observational study. He's just studying the deer and taking notes, maybe. Versus an experiment. Well, if the deer is walking by and the guy, pulls out a bow and shoots the deer, or just makes a noise and startles the deer and the deer runs off, well, that deer's not going to end up, in that pasture that he was headed for. The deer is going to run off or, be shot or whatever. But the point is you have disrupted the deer's day. All right. If you disrupt the population, all right, if you impose any kind of change on it, or if you impose a treatment on it, we call that an experiment. All right. Just sitting back and watching and not changing anything, observational study, versus changing something about that person or deer or fish or cow or a fox's day, imposing a change on their everyday life. All right. So an observational study does not disrupt the population. Just like another example, an opinion poll, I've asked your opinion on politics or something like that, and I write something down and you walk away and you go on with your day. Well, that doesn't change your opinion. I didn't do anything, I didn't argue with you or anything or try to change your mind. I just asked what your opinion was, and maybe I wrote down the results. That's an observational study. I didn't impose any change on you. I didn't disrupt what you were going to do. I just asked your opinion and wrote it down, and you went on about your day, versus an experiment which disrupts the population. All right, you impose a treatment and then observe what happens. An example from I read in a textbook is the goats in Hawaii. They're not native. Captain Cook dropped them off, and they multiplied, and now I guess they're running wild in Hawaii, just eating everything in sight. So they had a question about this plant, silver sword plant, that was native to the area, and they're going, I wonder if it's those darn goats that are destroying this plant. So what they did is they fenced off some areas, and the silver sword plant came back, and they said, you know what, it was those stupid goats. They were killing this plant. Now, how did they figure that out? They ran an experiment, all right? They fenced the goats out. They disrupted the goats feeding. The goats didn't get to go where they wanted to go. They didn't get to, perform what they were going to do during their normal day's feeding, because they were fenced out of this area that they would normally feed in. So anything that imposes a disruption or imposes a treatment or changes their day is an experiment. Now, since we're talking about experiment, let's talk about a double-blind experiment, all right? Just imagine that I am handing out pills in the classroom. The pill claims to take away your headache or your migraine or whatever, all right? Now, in one hand, I have the actual pain medication, and in the other hand, I have like a sugar pill. Now, I know which is which. That means I'm not blind, all right? You don't know which is which. That means you are blind, all right? That's a single blind experiment where I know what's in my hand. Now, a double blind experiment means neither one of us knows which pill is which. So maybe somebody just handed it to me, through a hole in the wall or whatever, they handed me this tray, and I don't know which pill is which, and I hand those out to you guys. Now, you don't know which pill is the real medicine, and I don't know which pill is the real medicine. So we're both blind. It's a double-blind experiment. So neither you, the individual, or me, the observer, know which pill is real. And the reason we do that is, I could give it away. If I knew which pill was which, I could give it away with, a wink, or maybe my face twitches or something like that, or you notice that I do something that gives it away. If I don't know which pill is the real medicine, then I can't give it away. We're both blind. We both don't know. Now, this eliminates something called, it diminishes, maybe not eliminates, but it diminishes the placebo effect. The placebo is lots of people, if you give them a pill, it could be a sugar pill, which does nothing, they still think that they feel better, all right? You could check with them the next day and say, hey, did that pill take away your headache? And they'll think that it did. Maybe that headache was going to go away anyway. We don't know that, but the subject thinks that the pill that was not medicine made him better. Well, that kind of screws up our study. That screws up our experiment when the placebo effect happens. The subject thinks that they got the treatment, and they claim to feel better, all right? That messes up our results. We need to know who got the real medicine and did it make them feel better. When these guys that didn't get the medicine say they got better, that messes up our results. All right, and the last two things I want to cover is a simulation and a census. A simulation, the easiest way to explain it is a flight simulator like Microsoft Flight Simulator, where you get on the computer and you pretend to fly a plane, and you make it take off, and you make it land, and you don't crash, all right? So even if you do crash, nobody gets hurt because it's a simulator. You're simulating the real thing. Lots of people, they actually do this. You can go to ground school and learn all about flying, but you're just sitting at a desk. And you can pass ground school. We can't put you in a plane yet because you might, kill everybody on board because you don't know how to fly really well yet. But we could put you in a flight simulator and let you practice on a computer, or we could put you in a plane with a real pilot and they could train you, all right? They could sit there and kind of hold your hand and show you how to do everything. But the point is you have to simulate. You have to practice, basically, over and over and over again before somebody will let you fly a plane for real. Another example is, testing new drugs. We don't really know what this new medicine's going to do, so we're kind of nervous about giving it to people. We don't know if it'll kill them or, give them cancer or what it'll do. We don't know if it's going to do what it's supposed to do. So you might try it on, rats or mice or monkeys or rabbits. We use all these animals as test subjects as a simulation, all right? We check and see what it does to them first because it's too dangerous to try it on humans right away, all right? So simulation is basically just practicing before you do the real thing. It's safer. It's safer to run a simulation first. And finally, a census. Well, the census is pretty straightforward. They're taking the census right now in the year 2020. And they're trying to go around to every house and, kind of peek their head in and ask how many people live in this house. And they might get the right answer and they might not, So the census is trying to be accurate. It's trying to gather info from everybody in the population. It's trying to count everybody in the population. But it's kind of impossible. You just cannot reach everybody in the population. There's always going to be that one person living back in the hills that won't let you in the house. And maybe there's 10 people in that house, but they won't let you in the house, so you don't know how many people are in the house. All right? So it's impossible. We don't know how many are in the population. It could be, fish in a lake. What's the average weight of a fish in a lake? Well, I'd have to get all the fish in the lake. I'd have to put them on a scale, and then I'd have to take that weight and divide it by how many fish there were. Well, that's never going to happen. I can't get all the fish in the lake. I can't get everybody in the population. So a census is kind of an idea. It might be close, but it's not going to be exactly accurate. It's going to be kind of a guess. Now, an exception to the rule is a census is easy as long as the population is small. So if I wanted to take a census of the students in my classroom and there's only 15 or 20 or 30 students in the room, well, that's easy. I can ask all of them a question, all right, and I'll get an exact answer. because my population is small, if the classroom is my population. All right, that's it, guys.